All right, here's the trick to doing this problem. Excuse me. Okay, so my first thought is to try u sub, where u would be 4x minus x squared. And if that's my u, my du would be 4 minus 2x. And if you factor a -1 out of that, you would have 2x minus 4. And the reason I did that is because I'm looking up here and I almost have a 2x minus 4. The missing -1 we could fix. So I'm going to turn that into a 2x minus 4 by subtracting 1 and adding 1 to the numerator. It's kind of a silly little trick, but what it allows me to do is change my numerator to 2x minus 4 plus 1 all over that denominator, 4x minus x squared. And now I can split that fraction. I can group that and do one antiderivative of 2x minus 4 over the square root of 4x minus x squared. And then I can group this one, the 1 over all that, and I can do plus the antiderivative of 1 over root 4x minus x squared. And both of these employ different techniques. The first one's going to be a little bit easier because this stuff that I did right here now applies to that green antiderivative. And so when I substitute, if I wanted to do substitution, I can now throw a -1 in here, and I've created my du. I need to offset that with the -1 out here. So now I have the negative antiderivative. All of that is my du in the numerator. So I have 1 over square root of u du, and we'll integrate that as u to the -1/2, which ends up being 2 square root of u plus c, but I'm going to ignore the plus c right now. So that this antiderivative ends up being -2 square root of u, and u was 4x minus x squared. And this one right here employs a tricky technique. We're going to have to complete the square in that denominator. So I'm going to make that 1 over, and it's going to be really weird. I'm going to write 0 minus x squared minus 4x, which is the same thing as what I have here. I'm going to complete the square, add a 4 here, and I was thinking that when I tried this problem a minute ago, I wrote a +4, so I'm thinking I need to subtract 4 out here, but this is actually -4 that I put in here. So I actually need to add a 4, and I'm going to do that by changing this 0 to a +4. So I'm going to get rid of that 0 and make that 4. And then I have my dx floating around out here. And the point of completing the square is it will allow you to factor that trinomial. So I have the square root of 4 minus x minus 2 squared. And I don't know how your teachers handle this type of antiderivative. This is what I call an inverse trig template, where my u is x minus 2, my u prime, which I prefer to have on top, would be 1, and I already have that. And 4 is what I call my value of a. A equals a. There's a profound statement. I'm sorry, 4 is a squared, so a is 2. And I use a template I give my students where it's u prime over the square root of a squared minus u squared dx, where u is some function of x. And that will always integrate to the inverse sine or the arc sine of u over a. So now that I've identified all of that, this is in that template of u prime over root a squared minus u squared. This antiderivative ends up being the arc sine of u, which is x minus 2, over a, which is 2. And so those are our two antiderivatives. So the overall answer ends up being -2 square root 4x minus x squared plus the inverse sine of x minus 2 over 2 plus a c. Hopefully I did not make any mistakes. I feel pretty good about that. But there are the techniques you would use in solving that one. That's a pretty beastly